Okay, so what you guys have learned till now is whenever you keep a ferromagnetic substance in an external magnetic field, it gets magnetized, correct? Now, see, to know which materials are ferromagnetic and which materials are not, okay? Now, we have something called as a hysteresis curve, okay? A hysteresis curve. See, this is hysteresis curve. Now, let me explain what is this. See, now suppose let's say you have some ferromagnetic substance. Okay. Now you have magnetizing field, that is the field what you are giving, and intensity of magnetization. Okay. So intensity of magnetization and magnetizing field. Now on the x-axis, we put the magnetizing field H, and on the y-axis, we put intensity of magnetization I. All right. Okay, now what we do is, so let's take a ferromagnetic substance, okay, some metal piece. Fine. Now, it is neutral, correct? Means not magnetized at all. Now what we do, we keep this particular material in the external magnetic field. Okay. As you keep on increasing the magnetizing field, what happens? This will also get, this metallic piece will also get magnetized. Now, as you keep increasing the value of H, it reaches a maximum point, that's basically a saturation, then it stops. No longer the value of I will increase, the intensity of magnetization. Okay, fine. So we reach the maximum point, or what we call as the saturation point. Then what we do is we switch off the magnetizing field. Okay, even if we switch off the magnetizing field, the intensity of magnetization will not be zero. Okay, so we reach this particular point, okay, on the y-axis. Fine. Then what we do is we need to make I value 0. See, if I value has to be 0, what we do is we change the polarity of the magnetizing field. So we start giving in the opposite direction. Okay, as you keep giving this in the opposite direction, I value becomes 0. Okay, so we reach this point. Then what we do the same process again. That is, we increase the H value but in the opposite direction. It reaches a maximum point, and then we switch off H. Basically, we make H is equal to 0. Okay, then I will also be there a little bit. Then what we do, we give the value of H in the opposite field again. Okay, and then again you keep increasing the value of H. So if you look at the curve, where the positive saturation is, you reach back at the same point, correct? So this particular curve is what we call as a hysteresis curve, or hysteresis loop, or hysteresis loss. All three are the same. Okay, now see what we started from O, we reached A, then B, then C, then D, then E, then F, then we reached back A, correct? So A, B, C, D, E, F, A, this is the whole hysteresis curve. Okay, now very important points in the hysteresis curve is OB, what you can see, that is the y-intercept OB, that is what we call as retentivity. Okay, now retentivity means, see, there is no external magnetic field, correct? But still, the ferromagnetic substance holds that magnetizing field, correct? Whatever the magnetizing field you're given, even though it is 0, it has certain magnetic property in it, right? So it is retaining the magnetic field. That is what we call as retentivity. Okay, then OC, what you can see, we call that as coercivity. So coercivity is basically for how long in the opposite direction, if you're giving the magnetizing field, the ferromagnetic substance can still retain the magnetic effect, okay, or whatever the magnetic property it has. Meaning, you have a ferromagnetic substance, okay, you start giving the external field in the opposite direction. For how long it can still retain the property, okay, so that is basically coercivity. Okay, so OB is retentivity, OC is coercivity. All right, now see this hysteresis though, why it is needed? Because see, you have some ferromagnetic substance, okay? Some ferromagnetic substance. Now, how do I determine which material should become a permanent magnet? Which material should become the core of a transformer? Okay, all these things, there, hysteresis loss is very, very important, or hysteresis loop. Because see, this hysteresis loop, what it gives you, okay, what does it indicate is the amount of work done in magnetizing and demagnetizing a ferromagnetic substance, okay, how much of work is needed per unit volume, okay. So this whole, the area of the whole hysteresis loop gives you the work done per unit volume, okay. Depending on what is the value of the hysteresis loop, we decide what material should be used for permanent magnets or electromagnets or core of a transformer. Understood? So in the next video, you will see where all do we use this hysteresis.